Okay, hello everyone. We are doing some trailing version 13.2 design reviews for Open Language here, and we are looking at astrographics. So,
Right. So we can look at the page, astrographics, or we can look at the examples
okay,
here.
so first of all, this is design.
Yep.
So, astro styling. It's kind of,
Yes.
we're getting these kind of funky words, but it's okay. I think it's pretty clear what it is.
Right. So the idea is to follow us as closely as we can the geo model, which has been successful. And we need this wrapper because in the future we want to overlay several stylings.
Yep.
So we cannot use just a list. And so the idea, I'm working on 3 different styles at the moment. So the first one is this, what I call dark sky, which is just black sky without the background image. And oh, I see.
3 gigabytes of ephemeris data.
So the moons require very large files. Yes. So
I thought I saw something that said we weren't going to default to be able to do the moons. Or are we? I mean,
at the moment, I'm adding the moons because it's nice when you zoom in and you see the moons. But yes, it requires a ton of data because each. Sorry.
No, but why don't we make it so that by default, I mean, if we know that the image is going, I mean, it's just like in many things, including geo, we make some commitment about what the image is, what the resolution is going to be, and we only download, to that zoom level or whatever. So similarly here, if we know we're showing the whole sky, we don't need to show the obscure moons of Jupiter.
Right. Yes, that's correct. At the moment, it's pre-computing them up front.
Well, that's crazy. What do you mean by pre-computing? I mean, it's pre-computing in the system or it's pre-computing in the ephemeris data?
Well, it's kind of preparing itself for the case in which you zoom in this map. And so it's actually going to place them there.
I think that's a mistake.
Mm-hmm.
I think it's like placing too high a zoom level in geo.
Yeah.
I have another question, which is, have we looked at whether we can use machine learning to reduce the size of these default ephemerides? I think we should feed that to the machine learning group and see what they can do. Or somebody should do that as a project to just see whether there's a way to do it, even approximately, because I mean, it's a performance goal, arrow, whatever, because there are people who do not want 3 gigabytes of data downloaded for this.
Yes. I mean, this is something that you do once, and because we had played before, I thought you already had these files, but
well, apparently not. Okay, question. I assume these files are in the CDN, yes?
Yes. Yeah.
Okay.
Yes. I mean, the right thing here is to have a low precision model for
by the
all
way,
of this.
I'm sorry, I'm just going to make a very trivial point, which is that in that progress monitor, it went from 3.21 to 3.3, and it jumped because it didn't have the extra digit. Whoever's dealing with those progress monitors, Avery, I think this is for you to chase, should make sure that it's a constant number of digits.
Yeah, I got it. I'm working on that project as well.
Okay, fine. I mean, what should happen is, what they should do, it's okay to jump once. That is, if you go from 9.99 seconds to 10.0, it's okay to jump once. You just don't want to be repeatedly jumping. See what I'm saying? From 3.1 to 3.21, you get what I'm saying? You don't want the number of digits. You can have it jump between 9 and 10. That's just one jump, right? But you don't want to be repeatedly jumping as you change the number of decimal digits.
Yep, I got that. Yeah.
Okay, all right. So this is, go ahead.
Yeah, I was going to ask you to try to manipulate, So that's the sky over the period of a day. So that H is hours. And so we see here the horizon is the green line, and we see the cardinal signs. Notice that this is always done so that you look up towards the sky. So east and west are reversed.
I have to say, if it is this is a common thing to want to have a kind of a moving planetarium-like experience like this. And by the way, I have another question. Let's say we wanted to use this data, our stuff in a planetarium. What format? Isn't that a spherical image story? That has to be converted to a spherical image to be used there. Am I right? Am I wrong? Is Jeff
They
here,
have,
maybe?
they have slicing software that takes images and video, and typically it requires production work behind the scenes to take given media and slice it, depending on how many projectors a given planetarium might have, because it varies from one planetarium to the next. So often requires custom work on site.
But I mean, we're planning this notion of a spherical image, which is kind of ultimately what such a place would need, even if they themselves deploy it in slices. Do you see what I'm saying? I mean, this isn't a spherical image, it's a projection into a flat screen. But and presumably in VR, we should be able to easily convert this stuff to a spherical image. Am I right?
Yes. In fact, Jeff and I have played with some sort of astrographics 3D, in which rather than having everything projected into a plane, we just add it into on a sphere.
That sounds nice.
But I saw the spherical image that the image processing team are creating, and that's for images so far only. So
I know, not for
this would require adding all this additional
so the
stuff.
question that I have is, if there is a standardized need for a, across the course of a day type star image, okay? Maybe we need a dynamic astrographics or something, separate thing. Maybe we need a dynamic astrographics that allows zooming too.
Right. So having this lighter background, which is why I by default remove the background image, which is in the next section, it's possible to do all those things dynamically. I mean, changing time, changing scale.
Okay. All right. So this has what, about, maybe a few hundred stars or something?
So we have a catalog for 100,000, and each map has at most 1,000, and we label about 25.
Okay.
And so then so the idea is that in the future we will have images background, but the images are hard to handle because they need image processing in every case because they change in time. And so this is what.
Wait a minute. The fixed stars. Wait a minute. You're changing the perspective on the Milky Way or something? How come? It's very far away.
Well, when time moves, the image has to move, right? So this brown line you see is the galactic plane.
I see.
So as the brown line moves, then the galaxy has to move. And because we have a single image in a rectangular projection, we have to deform it in real time, because the shape changes a lot with time.
Why aren't we caching this?
I mean, it doesn't help caching. I mean, users might want arbitrary dates, arbitrary positions, arbitrary frames. It's just too much freedom.
I see. Okay. And in terms of a highly compressed version of the Milky Way image, what level of compression are we achieving in this? I mean, I don't know even how we're storing it. What is it? Is it a GIF, or what is that actual image? It's image.
Tiles. It's tiles. It's using the same framework as Geo. So we have up to zoom 8 tiles. So we can zoom in and we see nicer images.
I see. Very nice.
So this is the exact same framework as Geo.
Okay.
Now, the thing is that in Geo, you always want that background image. But here, typically, the galaxy is not the most important thing you are interested in.
Tell that to whatever the various empires in science fiction. Never mind. Okay. So
planets and the sun, etc. If you go down, you see an image, for example, of what do you see if you zoom in around the galactic center. That looks nicer.
That's nice.
And also, when we go below something like 60 degrees of range, then we at constellations and deep space objects.
Constellation lines.
Yeah, exactly.
Yeah, not the
Illustrations are not on by default. You have to manually turn those on.
yeah, right. We don't want
Yeah.
the crab, you know, whatever. Okay, the term visible sky, especially when you have things like white sky, visible sky, it's hard to understand that means visible light.
Mm-hmm.
The sky and visible light. How can we fix that? I don't think that's a good name. I mean, radio sky, X-ray sky, those are okay. Visible sky just doesn't make it for me.
It could be interpreted to mean the sky that's currently visible from your location.
Yes, exactly. Exactly.
It's a little bit more verbose, but you could say visible light sky, but
Yeah, I don't think that's going to make it. Observed sky, telescopes, optical sky.
that's not terrible.
Yeah, that might work. Yeah.
What about just sky?
No, because there's too many different types of sky. Like
Yeah,
we
but this
said,
is the default one, right?
And I mean, dark sky doesn't make sense because that has all kinds of other meanings, but sky.
So that's how I'm calling the default above. The black one.
How about light sky? Because it is light, we see, right?
Yeah. I think optical is better. Optical sky.
light sky sounds weird if you also have dark sky, because then it sounds like you're saying light versus dark.
Yeah.
Which are not. Which one is the dark sky thing?
This one, the one which is black.
Yeah, purely vector. No images in the back.
In fact, one point of discussion at the end is whether this should
Maybe
be black.
dark, yeah, exactly. That's what I was just.
What, black sky?
Yeah.
Would be better.
Well, but the point is that perhaps this shouldn't be black. Black, I have the impression that black is too excessive. Perhaps it should be some sort of dark blue. I have examples at the very end. Perhaps you want to go to the very end at the moment and see this ground and daylight section. So it's more or less traditional to have some sort of lining, a bit of light around the ground, around the horizon.
Horizon haze.
Exactly.
Wait a minute. This is the horizon, the green.
The green line is the horizon, exactly.
So why are there stars outside the horizon?
Because it's kind of a transparent Earth. It helps, for example, showing when the sun is going to rise, because you see the sun before hitting the horizon.
That's really obscure.
It's a bit obscure, yeah.
Also,
Also,
I mean, why not do something that sort of, and Jeremy, we're going to need your input here, that kind of, sort of obscures these corners here. And I would say, if you're going to obscure the corners, you should bring this circle in a tiny bit from the edges.
Yep.
Because, and then, we
Go
don't
the
want,
other way and gray it, somewhat lighten the edges instead of darken. Like if,
yeah, I know, but I don't want to lighten it too much because that's going to end up being the main event. But I agree with you, particularly if the thing is on a background, on a white background here. I think graying, having these corners be slightly, melting into the background will be good. I don't know, why are we picking these particular colors for these?
it's purely random.
Green for grass, but other than that.
Yeah, it's purely random. In fact, probably color is not the best thing here. It would be better to have names like ecliptic, equator.
You mean have them labeled?
Yes. And,
that's
and
fine,
eventually even with ticks. This could be a good application of axis object because these lines have.
I like the idea of having ticks on them. That's cool.
Mm-hmm.
And that would get us out of this NW. You could mark the ticks around
Well, I think the cardinal directions are standard. It's very useful to orient yourself.
No, that's fine. But I mean, I think we can have ticks in different azimuth, azimuthal ticks, so to speak.
Right, exactly.
Going back to the mask we were talking about for the horizon, I'm not suggesting this for 13.2, but some other programs will often allow users to customize that to their own local horizon. If they go out with their camera and take a horizon panorama, they can often put that in and make it look like their local horizon.
Well,
But
that needs
that's
spherical
a bit,
image play.
it's a bit advanced for this first version.
No, but that needs spherical image, doesn't it? It needs projection from, you take the picture with your camera all around, and then you have to, do image stitching to get it together, don't you?
Yeah, unless you have a 360 camera, but yes.
Well, right. But, I mean, what would make it clear that, okay, we need to do some experiments here with this to look at what happens if we produce grayish, gray-green, gray-blue, for this outside piece here. Then with respect to these colors, I don't see any problem in having, and there's apparently no standardization in the color of horizon versus what's the blue one? Is that the ecliptic? Yeah, it's the ecliptic.
Yes, exactly.
And what's the red thing?
That's equator. That's equatorial plane, the equator of the Earth projected out.
Okay.
So Polaris is perpendicular to that.
Yeah. So one could imagine what would the circles of altitude look like? Or does that not make any sense?
Yes, it does. Do astrographics of astrogrid lines automatic.
Oh, cool. So now why is Polaris?
Because this is your zenith, right? So that's the point above, not necessarily Polaris. In fact, the distance is your latitude.
From Polaris.
Exactly. If you were at the North Pole, then Polaris would be exactly.
I might even understand how to navigate from a whatever. That's cool.
Well, it's the distance. It's 90 degrees minus the distance from the zenith. It's the altitude of Polaris is your latitude.
Right.
Which is the distance from the horizon to Polaris.
Correct.
Correct. Is this in 10-degree increments or what?
Yes, I think so.
40. Really?
10 or 15, whatever.
Well, okay. But I mean, so, and then there's the question of marking that, presumably on one of these things here.
Right. That would be nice too. I mean, instead of automatic, do quantity 10 degrees, 10 angular degrees, or 15 angular degrees. You can choose. Is that, yeah.
Okay.
That's presumably two numbers, right? You can give two numbers there.
Yes, you can.
But that's 40 degrees. I don't know where it thinks I am. Oh, look at that. 40 degrees. Fancy that. Huh.
Yeah, that's champagne.
I never really thought about this. Okay. All right. That's how you know where you are. Huh.
Well,
and then
latitude-wise, yes.
Yeah, longitude is more complicated. You have to know what time of day it is. Now, although this, oh, I see. The time of day we can get the position of the sun. Well, anyway, never mind. Let me not,
exactly. Yeah.
let me not try and learn navigation. Okay. We need to talk about colors.
Yes.
And what other things, other than the grid lines, nothing other than the horizon line is going to get repeated, correct? There's no multiple ecliptics or anything.
not multiple ecliptic, but you could have several sets of grid lines. So for example, Astro grid lines in Astro, you can say equatorial goes to 10 degrees. So in there, equatorial goes to 10 degrees, or ecliptic goes to 10 degrees. Yeah, there. Yes, or yes. I think it's a list.
A list, yeah, not a paren.
But probably a list. Because you can have several sets of grid lines at the same time.
Oh, wow. Okay, but that is profoundly not working in terms of color.
Yeah, indeed. So now that accumulation point is the ecliptic pole. If you did equatorial, then they would accumulate around Polaris, because Polaris is the equatorial pole.
Okay, Jeremy, we need different colors. Are you with us? Yeah.
I am. I was looking at Photoshop about this masking. Let me get back to you.
There is an Astro grid lines style option, and you can select.
Okay. It's very nice. I mean, it's very nice.
Mhm.
And so I also wonder that if these are a little bit too far away from the edge, they could be slightly closer to the edge.
Mm-hmm.
Small comment. Okay, let's scope out what else we want to talk about here. So I think optical sky is the most reasonable thing, and I would say minimal sky or something would be the right one for the case that you're calling dark sky.
I see.
Or star sky or something. That's not really right. I would just say minimal sky.
Mm-hmm. Okay. So then
now,
the idea
then
was
I think we want black sky that just doesn't have any, that has only the objects that you're interested in on it. No background. Or is that none? No, it isn't none, because it's still black versus white.
Exactly. Yeah.
Certain black sky.
So what is typical of books where they don't want to have so much ink? So in books, you will see the sky in white and the stars in black.
Yeah, usually colors are usually only ever shown if you have a black sky. You almost never see colors when you have a white sky.
Okay, so this will be white sky here.
Right. It's not well done yet, because we're still showing the colors of the stars, and they don't work well against white.
They're too pastel, so they don't stick out.
Well, but I mean, we always got to change the colors in that case. What the heck happened there?
So that's refraction. So this is including refraction, and of course, refraction works, has the maximum near the horizon, but then I deactivate it when it goes below the horizon, and you see this kink. So that's refraction being deactivated.
That's bizarre. Do I see that in this case as well? Oh gosh,
Yes.
I do. Kink
Yes.
there. Oh, that's crazy.
If we cover the below horizon, then we will not see that.
Fine. Well, in other words, but I think you should terminate the line before terminate that ecliptic line before you get there.
Yes, I mean, we don't have good clipping things, but I will find a way.
Okay, but I mean, but why does it not kink right at the horizon? Why does it go below the horizon and then kink?
Because we need some refraction beyond the horizon. For example, the sun is displaced above when it goes beyond the horizon.
Okay, but I think that is profoundly not what we should be displaying here. I mean, it's a very amusing effect, but we shouldn't display it here.
Right.
Now, okay, so, but part of the point you're making there is we can gray this down, but we don't want to get rid of it entirely, because then we'd lose the sun below the horizon, so to speak, which might in fact be refracted above the horizon.
Right. I think it's nice when you are studying sunset and sunrise. It's nice to see the sun touching the horizon from below.
What can we do about the star colors in the case? Because I think pumping those star colors up for this white background will be really nice. Right? It's just not going to work to have them pastel like this.
Right. The tradition is to have them black.
Yeah, but why don't we do better?
Mhm.
We can do better. I
Is
mean,
Is
given that
is
we're
that just a is that just a saturation change, or would that actually change the color too much? Would
no, it'll
pump
be a
up-
saturation change. I mean, it's look. I mean, is it the actual color of the star? Perhaps not. But it is. I mean, look, there's a bunch of white light. I mean, you know, as you go through the Planck spectrum, I guess I just don't know. I mean that we just have to try it. But I mean, whether that is the correct, 8,000 degrees, whatever it is for that blue star there, I don't know. We can certainly figure out what that color should be.
That's what we are computing. We are taking the temperature of the star and computing the correct color.
I
Which is why-
understand.
yeah.
But so
But the
I'm
other
asking-
stars are all invisible here, so you haven't adjusted those. They need to be more black, or you can't even see them.
But
Like-
if they're white, like the sun, for example, right? Notice that you faked the sun because the
Mhm.
sun is not yellow like that.
Right. The
So if
sun
you
and the
fake
moon are faked.
sun- Yeah. So if you fake the sun, you can fake the other stars as well and just pump up their saturation,
Mhm.
or take them take them appropriately into a color where they're going to make sense because they're white stars, right? And they're not going to do well against a white background.
Right.
So that's
Are you
a
going to
side-
provide a legend too for the colors? What kelvins they are?
we could, but
We could. Yeah, that's a good idea.
is that Mercury, that dot there? Right by the sun?
I think it's Venus. Mercury, I think we have it in gray, just a bit to the right.
Oh, wow. Okay. So if I wanted to, okay, let me ask this question. Could I show right around the sun? Is there an easy way to do that?
Yes,
Like
right,
analogous to geodisk.
right sun, the entity sun in the first argument, and then select an astro range of 2 degrees, something like that, 3 degrees.
But now can I say,
So that's the ecliptic in blue, and you see many other stars and other
okay,
things.
so Venus is in gray, which is bad, considering that.
Yes, the colors of the planets are kind of random right now.
Okay, so that has to be fixed in the white sky case.
Mhm.
What is IC and why is that gray?
The deep sky object,
Okay.
or like a galaxy.
Okay, but so if I now say, let's get rid of this. There's a certain argument that Venus that the font should be a bit bigger than the HD, whatever they are.
Mhm.
And likewise for the sun. Is that disk the correct size? What is the size of the disk of the sun?
Yes. So when you see the whole sky, the sun and the moon are enlarged because otherwise they are tiny. But then once you zoom in and they start looking real size, we do use real size. And for example, this is important for eclipses because we do get sun and moon
In the right shape. Yeah, okay.
exactly.
So if I go to Venus here,
Mhm.
and I go down here to, let's say, 0.5 degrees,
Mhm.
Venus is not a disk yet.
Right. So do Jupiter.
But I mean, if I go down to a sufficiently small size,
Yes, you would see Venus as a disk.
Yes, and its moons. Do even smaller.
I see. So let's do this. Wow. Cool. But there aren't any stars? And where's the eclipse?
This
Well,
is an
the-
interesting
the-
bias
the-
effect that you get. When you look at the whole sky, 100,000 stars sounds like a lot until you zoom in, and then you realize how sparse that actually is.
Where's the ecliptic?
Jupiter is not at the ecliptic. The sun is at the ecliptic.
Jupiter is near the ecliptic, but
I understand, but it was too far away from the ecliptic to show for the ecliptic to show up here.
Exactly.
Ah,
I think at very, very loud resolutions, there are no grid lines yet.
okay. So that's a thing to come.
That's yeah. For Jupiter, we show by default the 4 main moons. So I think you zoomed in a bit too much.
I don't know the angular size of Jupiter.
Do 0.1 degree. Something like
Okay.
that. Yeah. I mean, at some point, we should see the 4 ones. And with a manipulate, we should see, we would be able to
Reproduce
see
what
them
you
moving.
saw. Yeah. Cool. Okay. You know, I wonder if we should have an option to kind of pump up the visibility of stuff like this. Because I mean, you know, that shouldn't be a one, you know, in reality, that's going to be a 1 pixel, you know, it's arbitrarily small. But if that's what you're really trying to emphasize, and by the way, that color of Jupiter is pretty weird. Where did that color for Jupiter come from?
Some sort of average.
I see.
The right thing would be to overlay some sort of image here. And because we have information about the orientation, rotation, etc.,
Sure.
we could do it. But
You do it for the sun as well.
Yes, yes. And the moon. The most important one is the moon.
Yes. Yeah, we should do that.
like
I mean-
time-dependent textures.
For the sun, do we have the image? Do we actually have an image which has the sunspots? I mean, I know we know the number of current sunspots, but do we have the current sun image?
No,
Can we get it?
I don't know of a place that has a real time. You know, there's sites that have like snapshots throughout a given day, but they're not real time.
But it doesn't change that much, does it, during the day? I mean,
sunspots would be. I've seen movies where you can see them moving throughout the course of a day, but
really?
how much? Yeah,
I don't think it's significant. I mean, I think, you know, track that sunspot. I'm sure you can zoom in and see it, but by the time it just, they can't move that fast. The sun's big, you know. They can't move at I don't know what the maximum speed is. It's some hydrodynamic phenomenon where it's probably given by some plasma wave.
So now we're gonna need more weather data for
yeah. It's more like the sun's
corona
rotation period.
ejections.
We
It's more
have
like
what?
it's more like the sun's
We have-
rotation period you see, not the sunspots moving so much.
Oh, I see. But we know what, I mean, sun's rotation period hasn't changed in.
Yeah, it's 25 days. Sun rotates once every 25 days.
Okay. All right. So let's keep going here. So, I'm not keen to do something like this. I think this is, unless Jeremy can't come up with another solution, I think this is kind of weird. It looks like, you know, it's dawn at the horizon, which isn't really
Yeah, and
right.
it's obscuring the wrong parts, I think. The outer is what you wanna
Yeah.
obscure more.
This effect looks similar to like what you might see in, say, like Sky and Telescope. They have every month a you know, kind of a view of the fall sky or something like that, and their charts might look like something like this.
Mm-hmm.
Oh, we should look at the history of that. I mean, because some of these things, it's like, oh, you know, you always make the stars black. Well, that's because you were printing the thing in black and white. So what else are you going to do? Okay. All right. So we need these colors. Go ahead.
Yeah, no, I was going to say that here we have seen part of this already, so we can go fast here.
Yeah. Okay.
So these, yes, we have seen the Astro grid lines too.
What's show main planes? What is that?
Yeah, so the idea is that there are a variety of string options or parameters of the styles that indicate how to style things and how to turn on and off things.
Yeah.
So the main planes are the 4 main planes: equatorial, galactic, ecliptic.
I know.
Yeah.
It's almost like a style sheet.
Yeah. But I mean, main planes is just kind of a weird construct. So I'm sorry, just to clarify. So we've got black sky, white sky,
Optical sky.
optical sky.
But you call it minimal optical
Right,
white.
minimal sky, right? Minimal sky, but then white is also minimal because you don't have a see, black sky is just the objects you're talking about, but maybe it shouldn't be. Maybe none should be just the objects you're talking about. You know, okay, so minimal sky is just, maybe it should be black sky is the minimal case. Optical sky is the case with the actual
Image.
yeah, I mean, the other possibility would be like telescope sky.
Except that telescopes usually have a very narrow field of view.
Okay. I mean, is the only difference whether the Milky Way is there or not?
Well, that image has the Milky Way and many stars. Many more than we have as vector.
I see.
Yeah, it's literally made from the Gaia catalog, where it's just literally made up of all the stars that they've observed. It's enough that it actually looks like the real sky. It's essentially a rasterized point cloud.
Maybe it should be called realistic sky. What is the analog in geo?
Satellite.
Not really, because satellite comes from actual images. For example, this is not an image, and when you zoom in, you don't see the galaxies, which is a bit disappointing.
What do you mean? What do you mean?
You zoom in this image we have, and we don't want to see nebulas,
It's made from the Galaxy Star Catalog. I'm sorry, the Star Catalog from Gaia. It doesn't include anything other than stars.
So one could have something which is actually an image of the sky.
I mean, I don't know that thing exists of a global image containing the whole sky with good resolution.
Okay, we should maybe look for that. Okay, but that's a separate thing. So that would be a realistic sky.
Right.
It's a bit technical. You could say Gaia sky.
No.
More of an implementation detail, though.
Yeah, it's more of an implementation detail. Okay, so you're saying it has stars. Starry sky. It's a bit of a weird thing, right? Because you're saying it's not the actual view of the sky, it's the view of stars in the sky.
Right. So further down, we show how we represent other elements.
What it really is the galactic sky. It doesn't show anything outside our galaxy. Does it show like the Magellanic Clouds?
Yes, it does.
Does it show Andromeda?
No, I don't think so.
Then I think it should be called galactic sky, and that would give people the hint that it's going to show the Milky Way.
You could argue the large Magellanic Clouds are not part of the Milky Way. They're satellite galaxies.
I'm well aware. But if you say galactic sky, it's like sky in our galaxy, of things in our galaxy. What do you guys think of that? I think it's kind of a cool sounding name, at least.
Yeah, I think optical sky and galactic sky work for me, both.
I don't like optical sky.
Do you mean Milky Way sky or?
No, I mean, we're not committing.
Okay.
You know what I'm saying?
Yeah.
Although, fact is we're stuck in this particular galaxy.
For a while, yeah.
Indeed. Except for the photons and neutrinos and gravitational waves we get from elsewhere.
We may have a neutrino sky at some point, although it would just be the sun.
Yes.
They have neutrino telescopes now. So You can see the sun through the earth and such.
Right. And we could have a gravitational wave sky, which would be kind of interesting. I mean, if we had the, a background image that shows all of the events, all of the observed gravitational wave events. I mean, that would be a good example of something analogous to georaster. Actually, look, I mean, that would be a good exercise for all of this technology is, presumably there are coordinates, maybe just right ascension and declination, but there will also be a distance coordinate for all the gravitational wave events, which we could
But doesn't it all compile into the same catalog? So if you use an X-ray telescope, don't they do sort of extract basically the locations?
Yeah, but
goes into the same catalog.
There's right ascension and declination, but there's also a distance. There's a radial thing, which is not always very well determined.
Yeah, but that's as far as I understood, the catalog sometimes have radius, sometimes doesn't.
Yeah.
Now, the thing is that with each different observation, they will observe objects, but then the difficult thing is to correlate, to realize that this object in this wavelength is the same object in that wavelength.
Especially if newer missions have higher resolution possibly. So things that in the older catalog were one thing become two things in the new catalog. So it gets very messy.
Yeah, well, welcome to the ontology or taxonomy of almost everything. Those two butterflies were used to be one species.
And now diseases, same story.
Yes.
Right.
Molecular basis for disease all of a sudden.
Right. Okay, so let's look at this a little bit more and then we should wrap up.
So these are sections showing the various things that we can show independently. So astrogrid lines we discussed, and we can show several at the same time. So this is an example with several. Then constellations.
I think those should be in some kind of lighter. What are these? These are, I see, this is the borders of the constellations.
Mm-hmm.
And then, where do we get the little animals for the constellations?
Further down.
Ta-da!
This looks like the borders of Africa, like someone drew straight lines for the polygons.
Mm-hmm.
Yes, yeah, right. But that's what happened because, people need to know it's in Scorpio, for example. That star, that supernova just happened somewhere in Scorpio. You'd never seen that star before, but suddenly it's very bright. Am I right about that?
Mm-hmm.
Yes, they're mainly there for older catalogs catalog things based on their constellation. I mean, it's not really that important. It's just kind of a nice orientation. You want to know which part of the sky it is, and that kind of narrows it down.
Oh, you specified here the style.
Mm-hmm. Yeah,
exactly. So there are lots of
this is a heavily styled version.
Okay, but what would it be by default? Or there isn't a default yet.
There is a default. It's basically gray, all gray.
Okay,
basically,
so
what you see up above for Orion there. It's basically
Jeremy, etc. have to look at this.
Mm-hmm.
Okay, I mean, show constellations are automatic or true. Well, I don't think you should say constellations. I think you should say show. What is this doing? This is showing. I mean, you need a name for constellation images or something.
So there is constellation illustration, right? So see the style before where it says show constellations illustrations. Then that's activating the illustration. This nice.
I see.
Image. The constellation is just listing which constellations you want to see, because if you say true, it will show all. And then
I understand.
It's quite heavy.
Yeah. Right. We just had these custom drawn, right? All of these illustrations.
Yeah, we have about 65 done out of 88. We're working on the Southern Hemisphere now.
And there's no standard. We basically had to draw them ourselves because there's no standard.
Right. There's no standard. It's pure art.
Yeah. Okay.
There is no standard even for the lines.
Which lines? These lines here.
Yeah, the stick figures.
Yep.
I mean, some of them are very common. Everybody has the same view, but others, it's like there's variants of them for some other constellations where.
All right. Okay. So what else do we have?
Is there a bug in that? I see like these radial from the pinchers. There's these radial lines. Is that a bug?
Which radial lines?
So they emanate from between the two pinchers. There's a point, and then
Between
we've got
what?
these radial lines coming out of it.
Between the whats?
The pinchers, the
Oh, the
claws.
pincers of the
Oh
claw.
yeah,
See all these? Actually, there's a few
the
points of radial
triangulations.
lines.
There seems to be some kind of triangulation thing
Oh,
going on.
this thing
Oh.
here.
Yeah,
Could-
there's a couple of places where there are bugs like that.
Could be. So these are original field lines, field curves. Sorry, in
The super scorpion with it has some kind of ray gun as well as its pincers. No,
Yeah.
no.
I wonder if those go away if you turn off the transparency.
Yeah, they would go away.
I'll bet you they're
But-
overlapping polygons.
Yeah, but we may have to do something, Jeff. Because if you want them transparent,
Yeah,
this
exactly.
is a triangulation.
Yeah,
Yep.
this is the ray gun scorpion.
Yep. I don't know why I've never seen that before. This is one of my favorite ones to draw, and I've never seen this. So that's odd that we're seeing it here. So I'll have to look closer at that. But we typically did try to avoid overlapping polygon issues. So I'm amazed that we're seeing this.
And that's
That's
because
weird.
what? Because the scorpion is made of polygons or what?
Filled curves.
I see. Well, this looks like a bug.
Mhm. Yeah, we'll look into that.
This is pretty nifty. I mean, but some of these things look like they're distorted, and is that because the Gaia? I don't understand. These things don't look like circular stars.
So there is the image, which may have been distorted a bit by the projection, and on top of that, we put our stars. And actually, we have to be careful with things like precession, because this is an image representing the sky in year 2000, and so they could have moved by 0.3 degrees since then.
But that's the whole sky moved. It's not
Yes,
the proper motion of some particular random star.
exactly. I mean, it's something we can correct, but in a sense, it would be faking it, right? Because the image is a J2000 image.
You know, if the sky is frigging moved, I mean, the precession is due to the change of the frame because the Earth is precessed.
Yes.
So I don't think that's faking it. I mean, it's just like no more than anything else is faking it. I mean, we've changed our point of view, so to speak, or our orientation.
Mm-hmm.
Jose,
So
is it correct to
therefore-
say that you're not auto precessing the background? Is that correct?
Exactly.
Can we?
I think
We
it's got
could.
to precess.
We could. Yeah.
Otherwise, it's going to be way out of whack. It's going to have stars. You know, Polaris is going to be plopped, in one place, and there's going to be a shadow,
Mhm.
like a gravitational lensing of Polaris somewhere else.
Yeah. And it does happen in some cases if we are not careful with that.
Right.
And if you zoom in, you notice it even more.
Okay. Well, so we have to get that right.
Yeah.
All right.
So this is the solar system. This is an eclipse that's going to happen tomorrow, and this is how it's going to be seen from Linköping.
That's
So-
very neat.
It's partial everywhere, but it's better viewed from Northern Europe. So
And I assume, I mean, you're getting the order of polygons right. In this case, obviously, the moon is going in front of the sun.
good question. Not always in every case. We have cases of occultations in which we have the planets reversed and things like that. This is a functionality that still has quite a few things to fix, but it will be experimental.
Are we going to have a syzygies function that can find these kinds of, occultations and other kind of notable orientation, notable configurations?
Yeah, eventually, for sure. We have very precise data to compute those things.
Although it's not trivial to find the syzygy, we have to basically do some kind of iteration on the ephemeris.
Yes, indeed.
But that's why, it's like
It's not just that. It may depend on your location on Earth. Over the weekend, we found an example of a planetary conjunction between Neptune and Venus, I think, and it was only visible from the North Pole. So if you're not at the right place on Earth, you don't see it.
I see.
Right.
But in general, just like we have find root, we should have find
Yeah.
syzygy.
Find events. Event finding is a big deal.
Right.
Exactly.
But it's got to be syzygies because with auto-completion, people can even spell it.
I don't know. Syzygies are things in commutative algebra, right?
but they're also things, they were originally things in astronomy.
Okay.
They're these kinds of events. They're these kinds of, okay, what else do we need to look at here? I need to move along here. Saturn should not be green.
Yes.
Look, I mean, we have images of all these disks, and do we know their orientation? We do, don't we?
Yes. It's, I mean, just work, and we are short on time. So the last thing I wanted you to look at is these deep sky objects, for which we don't have images, but so we have representation. So, for example, so these are stars, so these are fine.
Mm-hmm.
These, so keep going down. So this is an example of how we can scale. So if you use this manipulate, you see a zooming around Betelgeuse.
Okay, where the size is some kind of fake.
It's all the way faked. Yeah, the stars are very, very small.
Based on brightness.
Yep.
I see. And is it logarithmic, or is it just, I mean, because the magnitudes, as you zoom in, you're just linearly increasing the area or linearly increasing the linear dimensions?
It's not exactly linear. It's slower than linear.
Okay.
So they would increase too much if we did it linearly.
But are you doing radius or area?
I think it's radius.
Okay.
And there's a way of controlling the maximum magnitude that we show. This is another thing that. Right.
Okay. That's cool. I mean, so the stars go out.
Mm-hmm.
That's nice.
So
I would just say,
Mhm.
Why do we say show star max magnitude? Just say star max magnitude. Because not the show, it's not showing the magnitude itself. It is the maximum magnitude.
Yeah, I think that's correct in this case.
Okay.
I don't think the word show is needed here.
Mm-hmm. So, for example, these are galaxies, right? So we don't have images for the galaxies. We only have ellipses of where they are.
What is that one? Is that Andromeda? I don't know.
Yes, yes, it is. Mm-hmm.
Yes, the label is a bit too small. It's placed at the center, essentially.
Huh.
With its
Shouldn't we
satellite
have
galaxies.
fills? Shouldn't we fill that? I think it would look better if the ellipse was filled somehow with some light fill. Seems more convincing.
Okay.
Given that, I mean, what we have, presumably, what do we have? The semi-major and minor axes and their orientation?
Yep.
Boy, that's big. 2 degrees? Really? Andromeda? That's
Yes,
substantial.
and it also depends on what you determine to be the outer edge of the galaxy. The longer your exposure, the more you'll see. So it's always somewhat of an estimate.
Sure. And if we had a dark matter telescope, we'd see it. Maybe.
I mean, there's actually out tendrils of our galaxy and Andromeda are already touching, of course. You know, depends on how faint you look.
So this is a case in which we show the background image.
Because the Magellanic Cloud is counted as being galactic.
Exactly. Yep.
Well, it includes stars that the Gaia telescope observed. So whether or not they're part of our galaxy or not.
Did it see any stars in Andromeda?
I don't know off the top of my head.
But so if I look at the Crab Nebula, for example, so just for but if I look at the Crab Nebula, if I say astrographics, let's see what happens if I just do this. Okay, where is it?
You have to say an astro range.
No, but where is the Crab Nebula?
It may not be up.
This is showing the whole sky.
So I understand that, but why isn't it indicating the Crab Nebula here?
Oh, I see. This is because we do the same as in geo. When we have an entity, we use it for localization. We don't show the point.
Unless I say point.
Exactly. If you say point, now this point is going to be a black point. So you have to say white also.
Is that really the right thing by default?
This is something that Arnoud had pointed out, that perhaps we should have a different default, but changing a default like that is going to change potentially.
Okay, what can I do here? If I say disk, can I have a number of degrees here?
Not degrees, do I don't know, 1, something like that? I don't. So this is projected coordinates. So
By the way, right now the Crab Nebula is about 22 degrees below the horizon, so it's not even up right now.
Right, that's too much. So.
I see. We're fortunate that we're showing things below the horizon.
Right.
Okay, so now I don't really understand. I hope we're documenting somehow those units. Right. So let's look at the Crab Nebula in a Astro range. Okay, now why am I not seeing stars there? Do I need to say?
Because it's gas. It's gas. It's not made of stars.
But there's no image.
By default, there is no image.
Okay, so how do I put an image in here?
Astro background goes to visible sky.
Don't forget the autocompletes, by the way.
Mm-hmm.
There's no Crab Nebula there. I mean, it's in our galaxy, right? Why isn't it?
But it's not. But it's not made of stars. It's made of gas. They don't. You know.
Maybe try the Pleiades.
No, I know those are stars, but
yeah. So
how do you spell Pleiades?
Plei.
Then what?
Ades.
And that's above the horizon.
Ades. Okay, but so that's indicating.
You can zoom out
with
a
these
bit.
squares.
See the rest of it.
Yeah.
That's big. The Pleiades is quite large, comparably.
It's actually several degrees, right?
Yeah.
Okay, what's that circle?
That's the boundary, the official angular radius of the Pleiades.
What are these boxes?
Those are other nebulas that are nearby. Diffuse nebulas are rectangles and squares. Star clusters are open circles.
Okay, but so this is yet another color we're going to need.
So these representations are standard in traditional books.
Fair enough. This is really wonderful stuff, guys. I really need to go. All right.
Are we ready to de-document anything? Or I'm sorry, defuturize anything?
Yes.
Okay, so with respect to the global Astro project, I think the main thing we didn't fully agree was this breaking the Astro observer, Astro frame freedom. Do you remember? We were discussing about having separate observer, base, etc. So that's the thing that I think is still missing to implement.
Just a minute. I'm sorry, say that again, please.
So I'm saying that what we have seen today is astrographics, and we will implement your changes. I think with respect to the global project, Astro project, the thing I think is still a bit in the air is the language for the Astro observers or Astro frames. And I realize Astro frame is actually not that good either because it collides with the frame option.
Oh, yeah, that's right.
So I think we may still have a bit of naming design there.
Astro reference frame? No, that's probably totally wrong. Is it wrong? Is it right? Astro reference frame.
I mean, as concept is fine. It's a bit long, but it will be fine.
That's what autocompletes are for. then we should go with that. Seems to me.
Mm-hmm. Okay.
All right. This is great. Sandra's commenting about with VR, you should be able to see the parallax for the stars. I don't think so. 1 parsec is, I mean, there are not very many stars within there, there are no stars other than the sun within 1 parsec. So
we can compute parallax, certainly. Seeing it here is more difficult. But for example, a bigger effect is aberration, and that's very clearly seen in the maps. That's 40 arc seconds.
Due to the motion of the Earth. Is that right?
Exactly.
Yeah.
Yep. Mm-hmm.
Around the sun, yeah.
I see.
Yeah,
Which he had
astronomers
to,
thought.
that one even surprised me. Jose had to show that to me because I had not encountered that before. That was pretty impressive. It's one of the documentation examples, though.
Well, great. Time for somebody to write an astronomy textbook based on this stuff.
Mm-hmm.
It would be really nice. This is really clarifying in so many things. Well, great. Okay, I got to run off. Okay. Talk to you all soon. Thanks, guys.